You're probably thinking of silence as the absence of sound, a hush, a lull, a quiet moment between the symphony's movements. Now close your eyes and picture a forest, any forest. Birds twittering in the trees, leaves rustling in the breeze, the distant murmur of a stream. You might feel peaceful, maybe even soothed, for most of human history, though such tranquil scenes would have been almost inconceivable. From the dawn of life on Earth until relatively recently, our planet was anything but quiet. It was a cacophony, a chorus of creaks, wails and bellows, rose and fell across land and sea. Creatures of all shapes and sizes sang to one another in a wild symphony of calls, from the terrifying roars of saber-toothed cats to the trumpeting cries of mastodons. In fact, the sounds of our world have changed so dramatically in the past few centuries that it's easy to forget what came before, forget everything you think you know about quiet. Here, the steady hum of electrical appliances is drowned out by the roar of a waterfall twice as tall as the Empire State Building. The chirp of crickets is lost in the bellowing of massive mammals weighing as much as 30 African elephants, and the gentle rustle of leaves gives way to the insistent drumming of torrential rain on broad, sturdy fronds. Welcome to Earth as it was 66 million years ago, to a time when our planet was a very different place. So let's set the scene. First, picture yourself standing at the edge of a dense, steamy jungle, the kind that covers much of the northern hemisphere during the late Cretaceous period. It's hot, sticky, and still. Then the sky cracks open and water comes down in sheets, pounding on broad leaves that form a thick canopy overhead. The ground is a carpet of giant ferns and other plants with stout trunks and huge lobed leaves that thrive in this relentless rain. Towering conifers rise above the trees, their branches heavy with cones, and everywhere there are strange plants with unfamiliar scents and shapes, including the ancestors of modern flowering plants, which are just beginning to diversify. Now, look up high above you. A flying reptile glides silently through the stifling air, its leathery wings outstretched. Below you, a relative of the modern-day ostrich uses its powerful legs to stride effortlessly through the undergrowth near a shallow pool. A duck with a bizarre bulbous nose filters for fish, while a turtle with a long neck and four-toed feet swims nearby. On the shore, a relative of the modern crocodile basks in the sun, its beady eyes scanning the water for movement. And on the forest floor, a beetle with impossibly large jaws scuttles away from the snapping jaws of a strange fox-like predator with enormous claws. This is Earth 66 million years ago, a world that's both familiar and bizarre, and here the action unfolds against a soundtrack unlike anything we know today. To understand how to fill in the missing sounds of the ancient world, let's take a closer look at some of its inhabitants. After all, animals communicate in a variety of ways, but sound is often a key part of the mix. Take that duck with its duckbill. Modern ducks quack, whistle, scream, hiss, and more. Their calls carry across ponds and sometimes for miles. But what did its ancestors sound like? Well, to find out, researchers can examine the duck's evolutionary relatives to see if there are any correlations between their calls and physical traits. For example, they can study the shape of a duck's skull to get clues about its sounds. Ducks with flatter, shorter skulls tend to have shorter, lower-pitched calls. Those with longer, taller skulls produce longer, higher-pitched calls. With this knowledge, scientists can make educated guesses about the sounds of ancient ducks. But not all ancient animals were built the same way. Consider the mastodon, a relative of the elephant that lived in North America and South America during the Pleistocene epoch. These massive mammals had long, straight tusks and small ears. Unlike modern African elephants, which have curved tusks and large ears, modern elephants use their tusks to trumpet, a loud call made by exhaling forcefully through the trunk while simultaneously closing the mouth, pushing the cheeks forward and closing the nasal passages. But mastodons were different enough from modern elephants that we can't assume they made the same sounds. Instead, scientists have reconstructed their probable calls by studying the shape of their skulls. Mastodons had tall, narrow skulls with large sinuses, hollow spaces within the skull connected to the nose. These structures acted as resonating chambers, amplifying and changing the sounds made by the mastodons. By modeling the acoustics of these chambers and comparing them to the sounds of modern-day relatives, scientists estimate that mastodons probably made low-pitched bellows, maybe sounding something like a foghorn. And then there's the saber-toothed cat, a fearsome predator that hunted during the Pleistocene epoch in both North and South America and Eurasia. Cats are known for a wide variety of vocalizations, from the throaty meows of house cats to the growls and hisses of big cats. But saber-toothed cats were larger than any modern big cat, with long, pointed ears, short, furry tails and bodies that measured over 8 feet long. And instead of roaring, they probably made a range of harsh sounds to communicate. After all, studies show that felines with shorter, broader skulls and smaller auditory bulla, or the bony structure surrounding the middle ear, tend to produce higher-pitched, harsher sounds than those with longer, narrower skulls and larger bulla. Saber-toothed cats had skulls that fell somewhere in the middle, suggesting they could produce a range of sounds. Ultimately, scientists have recreated the saber-toothed cat's call by modeling its skull and comparing it to the calls of related species. They concluded that the saber-toothed cat probably made a sharp staccato meow, kind of like a yowl mixed with a cough. Now, imagine these sounds echoing through the prehistoric landscape, blending together with the calls of hundreds of other creatures. There was probably no such thing as silence in this world, only a complex, ever-changing soundscape. And that raises a fascinating question. How exactly do scientists hear the voices of creatures that have been silent for millions of years? Some researchers recreate the sounds of ancient creatures by studying their relatives and using computer models to simulate their calls. Others focus on the morphology of bones related to sound production, such as the hyoid bone in the neck or the malleus incus and stapes, otherwise known as the hammer, anvil and stirrup bones in the middle ear. For example, the hyoid bone is a U-shaped bone in the neck that supports the tongue and helps produce sounds. The hyoid apparatus, which includes the hyoid bone and the muscles attached to it, is especially useful for reconstructing the sounds of extinct vertebrates because it's rarely preserved in the fossil record. Instead, scientists rely on its structure in living relatives. The hyoid apparatus of modern primates varies greatly in length, flexibility, and mobility, reflecting the diversity of sounds they produce. By comparing the anatomy of extinct creatures to that of their living relatives, scientists can gain insights into their sounds, and in some cases, they can even estimate the strength of their vocal muscles. In the case of mastodons, scientists examined the structure of their hyoid apparatuses and compared them to those of modern mammals. They found that mastodons had relatively weak hyoid muscles, which suggested that they couldn't produce loud, low-frequency sounds like modern elephants. Instead, they probably made lower-pitched sounds similar to the low rumbles of gorillas and chimpanzees. Meanwhile, saber-toothed skulls offer clues about how they produced sound. The bones in their middle ear were thicker and heavier than those of other cats, suggesting that they had strong jaw muscles and could create loud sounds. But the exact sounds they made remain a mystery. Now, let's return to that prehistoric forest. Imagine the cacophony of calls filling the air. A mastodon trumpets as it shakes the ground with each step. A saber-toothed cat yowls and coughs as it stalks its prey. And the sound of dripping water is punctuated by the buzz of beetles and the snap of a twig. As you explore this ancient environment, every sense is engaged. The humid air is thick with the scent of decaying vegetation and the calls of unseen creatures. Strange plants with vibrant colors and unfamiliar textures surround you, and the ground is a tapestry of giant ferns, gnarled tree roots, and slippery mud. To fully experience this world, you need to engage your other senses. 2. Hear the low rumble of a distant earthquake as tectonic plates shift and reshape the planet. Feel the spray of a nearby waterfall on your face as water crashes into a deep canyon below. Taste the tempts of berries growing on vines that snake through the trees. Smell the musky odor of a passing mammal and hear its heavy footsteps shaking the ground beneath your feet. All of these sensory experiences combined create a vivid picture of life in the past, and they highlight just how rich and textured the history of our planet really is. By piecing together the sounds of ancient creatures, we gain a deeper understanding of the world they inhabited and the sounds they made. We also learn more about ourselves and our place in the natural world. So next time you find yourself surrounded by the noise of modern life, take a moment to close your eyes and listen. Imagine the sounds of a saber-toothed cat, the rumble of a mastodon, and the buzzing of prehistoric insects. Let your mind wander to a time when Earth was a cacophony of calls and the orchestra of life played on. For, in doing so, we remember that the world was never truly silent and that its chorus of voices has been woven into the very fabric of our existence.